Welcome to Course 4, Foundation, Certified Supply Chain Professional, CSCP, course, by SPAO Academy. Topic 2, Global Supply Chain Networks, Section 9, Supply Chain Metrics and Reports. Lesson 3, Circular Economy Impact on Metrics. Circular Economy Impact on Metrics. Welcome to Lesson 3. In the previous lessons, we discussed traditional supply chain metrics like on-time delivery, inventory turnover, and perfect order rate. These metrics were designed for a linear economy, a take-make-dispose model. However, as businesses face increasing pressure from consumers, regulators, and the finite nature of resources, many are transitioning to a circular economy model. But how do you manage what you can't measure? The shift to a circular economy fundamentally changes what success looks like. In this lesson, we will explore how circular principles force us to redefine traditional metrics and introduce entirely new ones to track progress toward a regenerative and waste-free supply chain. 1. Linear versus circular. A shift in mindset. Before we dive into the metrics, let's contrast the two models. Linear economy metrics focus on efficiency and volume. The goal is to make a product as cheaply as possible, sell as many as possible, and get the next order out the door. Value is realized at the point of sale. Circular economy metrics focus on resilience, longevity, and value retention. The goal is to design out waste, keep products and materials in use, and regenerate natural systems. Value is realized over the entire lifecycle of the product and its materials. This shift requires us to ask new questions. Instead of, how fast can we make this? We ask, how long can this last? Instead of, how much did we sell? We ask, how much did we recover? Instead of, what is our cost of goods sold? We ask, what is our cost per use? 2. How circularity redefines traditional supply chain metrics. Many of the metrics you already know take on a new meaning in a circular supply chain. Let's look at a few key examples. A. Inventory turnover. Traditional view. A high inventory turnover is almost always good. It means you're selling products quickly and not tying up cash in unsold stock. Circular economy view. The interpretation becomes nuanced. A circular business model might involve product as a service, PaaS. Here, the manufacturer retains ownership of the product, e.g., a washing machine or a jet engine, and sells the usage. Impact. Inventory turnover becomes less relevant. The inventory is a long-term asset that generates revenue over many years. A high turnover might actually indicate a problem. Perhaps the products are of poor quality and are being returned frequently, or the service contracts are too short. The focus shifts to asset utilization and durability. B. Cost of goods sold, COGS. Traditional view. COGS is the direct cost of producing goods. The goal is to minimize it, often by sourcing the cheapest virgin raw materials. Circular economy view. COGS expands to include end-of-life management. Using recycled content might have a higher upfront material cost than virgin plastic. The company must now factor in the cost of take-back programs, reverse logistics, and the disassembly and recycling of products at the end of their life. The metric evolves into total lifecycle cost, which accounts for initial production plus recovery and remanufacturing costs, compared against the value of the materials and components recovered. C. On-time delivery, OTD. Traditional view. Did the product arrive at the customer's dock by the promised time? Circular economy view. OTD expands to include the reverse flow. A new metric emerges, on-time return. Did the used product arrive at the remanufacturing facility on time as scheduled? This is critical for planning remanufacturing capacity and ensuring a steady flow of core components. It also includes the timely delivery of refurbished goods back into the market. 3. New metrics for the circular economy. Beyond redefining old metrics, the circular economy introduces entirely new categories of key performance indicators, KPIs. These can be grouped into three main areas: materials, products, and recovery. A. Material metrics, design and sourcing, recycled content ratio. The percentage of recycled material used in new products compared to virgin material. Formula. Weight of recycled material used, total weight of material used, x 100. Material Circularity Indicator, MCI. Developed by the Ellen MacArthur Foundation and Granta Design, this is a more sophisticated metric. It measures how restorative the material flows of a product are. It considers the amount of virgin material used, the amount of recycled, reused material used, the product's lifespan compared to the industry average, the destination of the product at the end of its life, landfill, recycling, reuse. B. Product use metrics, business models and longevity, product utilization rate. In a linear model, many products, like power tools or cars, sit idle for 95% of their life. Circular models, often enabled by the sharing economy, aim to increase this. Formula: actual usage time, total potential usage time, x 100. Average product lifespan measures how long a product is used by its first owner and subsequent owners before it is discarded or returned. The goal is to extend this through durable design, modularity, easy to repair, and upgradability. Service level, for PAAS, for a product as a service model, this metric tracks the uptime and performance of the product. If the product isn't working, the customer isn't paying. This incentivizes the manufacturer to build highly reliable and durable products. C. Recovery metrics, reverse logistics and end-of-life, return rate, take-back rate. The percentage of sold products that are returned to the manufacturer at the end of their use. Formula: units returned, total units sold, x 100. Recovery rate: what happens to the products once they are returned? This metric breaks down the percentage of returned products that are remanufactured, restored to like new condition, repaired, refurbished, fixed and resold, recycled, broken down into raw materials, landfilled, incineration, sent to waste. The goal is to drive this to 0%. Waste to landfill ratio: a straightforward but critical metric measuring the total waste generated by the supply chain, including packaging and manufacturing scrap, that ends up in a landfill, relative to production volume. Summary and key takeaways: the transition to a circular economy is not just an operational change, it's a philosophical one that demands a new measurement framework. Old metrics are reinterpreted. Efficiency metrics like inventory turnover and COGS must be viewed through a lifecycle and service-based lens. New metrics are required. You must start tracking the flow of materials, recycled content, the intensity of product use, utilization rate, and the success of your reverse logistics, recovery rate. Value is measured differently. Success is no longer just about the speed and cost of the initial sale, but about the long-term retention of value through durability, reuse, and material regeneration. Reporting becomes holistic. Circular metrics bridge the gap between operational performance and corporate sustainability goals, providing a more complete picture of the supply chain's health and resilience. In the next section, we will explore the technologies that enable the tracking and management of these complex circular supply chains. I really appreciate you spending your time with me today. If you want to learn more, don't forget to hit that subscribe button. Your like means the world to us and helps this channel grow so we can continue bringing you great content. Thanks again, and see you on the next video.